Hi everybody, and welcome to lesson 1.3 part 1. We're going to talk about some ways of describing quantitative data today. Following learning targets, you can pause and read through them, and we will revisit these learning targets as usual in the important ideas box after the activity. So to start the activity, we're going to take a small sample of data for how many different colleges that this small group is applying. The data is listed here, so why don't you go ahead and copy that data down and then work through parts 1 through 5, and we will debrief after. So here I am with parts 2 and 3 done. The mean, of course, is the average. You'd add up all of the individual items, divide it by the total number of data points. I wrote a 5 here, but I really meant an 8, so let me fix that. Because there's 8 pieces of data, and you'd add them all up, divide by 8, you'd get 5 for the mean. Pardon me. And as far as the median is concerned, what you'll want to do for the median, I have in red here, you'll want to arrange the data in ascending order, descending, it doesn't matter, and find the middle. The median, remember, is the middle term. So you count in from the end. You can like cross off the data values if you want. That's how it works pretty nicely for that. And now it's going to be the one that's right in between these two. Fortunately, we have them. Them both are 5. We have them both as 5. So the median is 5. So when you see the word compare, I crossed it out inadvertently when I was underlining the 5 there. But when comparing, remember, you do want to use comparative words. So the mean and median are the same. 5 colleges. For part 3, of course, the range should be pretty straightforward. Max minus min, 5 colleges is the range. The next part deals with this table and computing what's known as the standard deviation. What you should do is fill in the table with all of the data values and follow the directions for each of these. The distance from the mean, square them, add them, all that kind of stuff. All right, so hopefully now you have filled in this table. We take each of the 8 individual data points, find the distance from the data to the mean. So in other words, subtract the mean, get all these numbers. And then we're going to square each of those distances to the mean. We'll talk about why we do that in just a second. And then add them up. So the average distance is squared is 2.5, because once we add them all up to get 20, we divide by 8 because there's 8 data points. 8 data points and get 2.5. Now this would be the average squared distance from the mean. So how do we get from the average squared distance from the mean? Well, we take the square root. So the square root of the average squared distance, square root that, you get 1.58. So how are we interpreting that 1.58? We're interpreting that 1.58 as the average distance from the mean. So on average, each data point is 1.58 units from the mean. Okay. Now what we're going to do is real quick go over to Staplet and enter this data and find the summary statistics to verify our work and compare what Staplet tells us to what we came up with already. So let's go head over there. First things first, make sure that we are using the one quantitative variable single group, because we have exactly that. Enter our 8 data points. Hit begin analysis. Of course, it'll make a dot plot. The dot plot isn't terribly interesting right now. What I am terribly interested in right now is these summary statistics. You've probably seen them come up so far. We haven't really talked about what they are, what they tell you. And of course is the number of data points. The mean is what we calculated earlier at 5. The median, we calculated the same thing earlier as 5. You got your min, you got your max. Q1 and Q3 are the topic of the next lesson, 1.3 part 2. So you can hang tight on that. And then this number is the thing we're interested in most, and that is SD, standard deviation of 1.69. So that does not match what we just calculated. So what in the world is happening? So the standard deviation we just found we calculated, remember comparative words, was smaller. We calculated 1.58 than the standard deviation in Staplet, 1.69. All right, why that is, again, we'll talk about in just a few minutes. And let's play with standard deviation just a little bit more to see what happens, and mean and median, of course. Let's just play around with that for just another moment. And what we want to do is we're going to add me to the mix. When I was in high school, I applied to 20 colleges. For what it's worth, that's false. For the sake of argument, let's call it true, though. 20 colleges. Add me to the mix and find out what happens to mean, median, and standard deviation. Take a minute, do that, describe, use your comparative word. So what happens when you add 20? When you add a new data point of 20? Well, your summary statistics change. Notice your median doesn't change at all. Your standard deviation and your mean, however, both change. So the new mean, 6.667, new median, 5, new standard deviation, 5.244. New median is the same as the old, 5 colleges. The new mean and standard deviation are higher, comparative words, than the original values. This is because the outlier greatly increased the total, which affects the mean and standard deviation, right? The total, the sum, affects the mean and standard deviation, but it doesn't really impact the median that much. The sum total is not important for the median, all right? Because you're counting down from the edges, remember, for that. So just adding a 20 out here doesn't really impact what's going on in here for the median, all right? So let's move on to the important ideas. I'll be back in just a second as I lay. So as always, the important ideas always come back to the learning targets. So measures of center, mean and median, the measures of variability, range and standard deviation. Tomorrow we'll get to this IQR thing. Well, maybe not tomorrow, 1.3 day 2. So right now we did range and standard deviation. And then let's talk a little bit about how outliers and skew affect things. So the mean, of course, is always the sum of the data values divided by the number of data values. In statistical formulae, you'll get X bar is always the mean. And the formula for mean is sigma x sub I over n. Sigma x sub I, remember capital sigma is, that was a terrible sigma. Capital sigma always stands for sum, right? For sequences and series, you would have done that in pre-calc, and maybe algebra 2. So sigma x sub I means the sum of all of the individual x values, all of the individual data values gets you x bar for the mean. And once you do that, divide by the number of data values, or n. Of course, your median is your middle point of a distribution. You'll always use your median in skewed data. We'll see how that worked. Remember right here, remember how much this outlier affected the mean versus it had little to no impact on the median. So you'll always use the median in skewed data, whereas the mean you'll use in symmetric data. All right. For measures of variability, the range is, of course, nice and straightforward, max and min. Can't always paint a super accurate picture. So we also have this mysterious standard deviation thing. Now remember, we got two different values of it earlier. The formula that you're going to do, remember, was based on the sum of a whole bunch of distances from the mean squared. So the sum of the individual data values minus the mean, the x bar, and we squared that. So we had x sub I minus x bar, and each of those we squared. So that's, we added them all up, and we divided, in this case, we divided what by n, right? So how did we, and we got 1.58. Where did this 1.69 number come from? What we actually got that from was dividing by 7 instead. So I don't know why I wrote n minus 7. It's n minus 1. Now, we'll talk about why that's n minus 1 well later in the year. Right now, this is going to be one of very few times that we're just going to kind of take that with us and accept that. But right now, the 1.69 comes from the fact that we used n minus 1 rather than the value n. All right, so we're never really going to have to, calculate the standard deviation by hand, but I think it's really good to understand where that formula comes from, what standard deviation is measuring. So with that said, the n minus 1, if you're calculating these things on a TI-84, you're going to want the SX value to get you the n minus 1, whereas the sigma x will be population standard deviation, uses n. We are always going to use this one, the SX, because we're talking about sampling. Again, as the year goes on, that'll make a lot more sense. Once you have the standard deviation, interpreting the standard deviation is really important. Whatever the context is typically whatever the standard deviation is typically units from the mean. So on average, like we said here earlier, on average we were 1.58 colleges from the mean, or actually 1.69, the typical variation, standard deviation from that mean. All right, the last thing we got to talk about here is just to reiterate one more time that the mean and standard deviation are considered non-resistant values to outliers. In other words, outliers greatly affect the mean and standard deviation. So you will only use these in symmetric data to get an accurate portrayal of the center, whereas the median is considered to be resistant to outliers. So you'll use that in skewed data. Just like we did earlier here, how the median didn't change, whereas the mean and standard deviation did. So now use your new knowledge to check out these check your understanding questions. I'll add the answers and debrief on them. So now that you had a few minutes to check out the check your understanding problems, we'll debrief on them in order to find the mean weight, of course, add up all of the individual data values, divide by the number 23, and you've got 9.935 pounds. Always include units, always include context. All right. The median weight, you'd want to put all of the weights in ascending order. Since there are 23 values, the 12th value is the median, because you've got 11 values below, and you've got the 12th value, and then 13 through 23 are also 11, right? 1 through 11 is 11 values. The 12th value would be 6.6, and that would be the median, because you'd have 11 values above and 11 values below. Last, would you use the mean or median to best summarize? I would use, again, you can read, But what's really important is context and full sentences. An incomplete answer would just be saying, I would use the median. First of all, you see the word explain, and also in your explanation, you should always include a context. So definitely let me know if you've got any questions or comments on this, and